Have you ever wondered how large networks, like those in big companies or schools, keep everything organized and secure? Enter VLANs, a virtual local area networks. In this presentation, I'll explain how VLANs help divide and organize networks while also providing security. Imagine a party with different groups of people chatting in smaller circles. That's what a VLAN does. It allows you to divide a large network into smaller but organized groups. Each group, or VLAN, communicates internally, but not with other VLANs unless allowed. Why are VLANs important? They help by 1. Organizing the network, group devices logically, for example, by department, while improving security. Devices in different VLANs can't talk unless permitted, reducing network congestion. By keeping communication within smaller groups, you limit unnecessary traffic. VLANs work at layer 2 of the OSI model, where MAC addresses live. Devices in the same VLAN can talk freely, while communication between VLANs requires a router or a layer 3 switch. When data is sent across a network, it's sent in a frame. VLANs use tags to label frames with VLAN information, so switches know which VLAN each frame belongs to. This tagging is done using the 802.1q standard. Within a VLAN, devices can communicate easily, like in VLAN 10 for marketing. Between VLANs, to talk to devices in another VLAN, like VLAN 20 for accounting, you need a router to route traffic. What happens when your VoIP phone and computer share the same cable? Voice VLANs. They separate voice traffic from regular data traffic to 1. Improve the call quality, 2. Prioritize the voice traffic, and 3. Simplify cabling. In a typical office, phones are assigned to a voice VLAN. Computers are on data VLAN. The VoIP phone assigns voice traffic to a voice VLAN and passes the computer traffic to the data VLAN all over the same cable. Versus untagged VLANs. Untagged VLANs, traffic moves without the VLAN tag. Devices think they're on normal network. Tagged VLANs, VLAN tags stay with the data as it moves. This is used when carrying traffic for multiple VLANs on the same connection, like for example a trunk port. PVID. The PVID tells a switch which VLAN to assign to the untagged traffic. If a port has a PVID of 10, all untagged traffic will be sent to a VLAN 10 by default. A VLAN trunk carry traffic for multiple VLANs between switches. Think of it like a superhighway that multiple groups can use. A link aggregation group or a LAG, on the other hand, combines multiple physical links into one to increase bandwidth and provide redundancy. Some vendors like to call LAGs trunks, so that's why I include this slide. Imagine setting up a school network. Let's take VLAN 10 for teachers, VLAN 20 for students, and VLAN 30 for guest Wi-Fi. Now the teacher's devices are isolated from student devices and guests can't access internal resources. This keeps the network organized and secure. To sum up, VLANs group devices logically and securely within a network. Voice VLANs help improve phone call quality. Tagged VLANs carry traffic from multiple VLANs on one connection, while untagged VLANs don't use a VLAN tag. PVID assigns untagged traffic to the correct VLAN by default, and VLAN trunks manage traffic for multiple VLANs, while LAGs combine links to increase bandwidth.